Ms. Pankaj, Ms. Sneha, and Mr. Srinivas, the resource person for this expert talk. We welcome you once again, and over to you, Mr. Pankaj.
So thank you, Keshav, and thank you to the whole CDAC team for inviting EXUSIA to participate in this Tech Talk session. So first of all, I'll introduce myself. I am Pankaj. I am part of talent acquisition team in EXUSIA, and I also lead campus hiring in EXUSIA. So yeah, you guys will have more interaction with me in our upcoming hiring events. So, and alongside me is Mr. Srinivas Lanka. He is a designated partner of the company, and he also heads data analytics vertical in EXUSIA. And he will be the main person leading this session and provide you insight about data analytics and what are its uses in the real life scenario. So thank you all for joining, and hope we all gonna have a good session, and you're gonna have we'll get to learn more about data analytics after this session. So over to you, Srini.
Hey, thanks, Pankaj. Okay, so again, thanks everyone for taking time off to attend this session. Hopefully, this can provide you a lot more insights. Obviously, 1 hour is too short for this topic, but would definitely want to at least ignite your interest and spark some thoughts in terms of moving towards data analytics as a career. So a quick intro about myself. I am with EXUSIA for about 5 years now, and I lead the data engineering and analytics practice at EXUSIA. Come with 25 years of industry experience, and that kind of started off from the days of Foxtrot, DBase. I don't know if those terms still are relevant and understandable by you guys, but yeah, pretty much started off when the databases were evolving into more of a decision support systems. And now we are already there at the cusp of really looking at data and big data world, moving away from analytics and embracing on AI, ML, and so on. So hopefully I can give you a perspective of what is happening in the industry besides the core aspects of analytics itself. Again, well, I'll definitely talk about that. A bit of the away from work, what do? I definitely have a couple of hobbies to keep myself engaged. I do enjoy driving and going off to places that are off the beaten track. So definitely an opportunity to meet up people who are interested in kind of exploring places. Besides, I also have interest in gardening. Hoping that at some point of time I'll be able to really become self-sufficient with my terrace gardening. So that's my aspiration apart from work. Okay, so getting on to more serious stuff over the course of next 50 minutes, what is it that we will do? While I understand your interest is in data analytics, I do want to kind of start off with what data is, how the data trends are evolving, give you an insight into what are decision support systems intended to do, what are the various components. And then you often hear a lot of the jargon thrown around: business intelligence, data analytics, data science, business analyst, data scientist. So we'll try to put those terms into perspective. Are they really one and the same? Is there an overlap between them? If so, what is it? So that's the thing that we would definitely try and achieve. Then we will drill down into understanding business intelligence, from where the overall analytics word has taken off. And then we'll move on to data analytics, which is the focus area for us, and see what is happening in that space. Finally, we'll also look at a bit of the things that are shaping the marketplace and the opportunities in this specific area. And probably most important for you, I'll also want to give you an understanding of what are the various career options, career paths available if someone wants to kind of take this on as a serious interest area. Okay, so EXUSIA has been working with CDAC for a fair length of time. So a lot of alumni from CDAC have been with us and been part of our journey. So I wanted to give you a bit of sense of what EXUSIA does and why we are really good at analytics, and what really makes us tick in this workplace, and then we'll get into the core business. So EXUSIA has kind of come into existence essentially to solve the problems that we see as ever growing in the space of data. You see the explosion of data happening all around us. Some numbers thrown in, 2.5 quintillion bytes of data coming in every day, right? So all of this data means that it's not just about storing data, but making sense of this data. And this data is coming in various formats. So we saw an opportunity there to really kind of make a difference to the outcomes, and that's why we chose that as our specific target area. And that also brings the point about why we are here and the competency that we have to really be able to deliver these insights for you. From our execution perspective, we essentially focus on 4 key things. One, when you actually come down to analytics and a client actually or a business actually investing in analytics, it's always a question mark, why should I even spend? And there is in the question of return on investment. So in analytics, when you talk about data numbers, it is equally important that you are able to justify the return you are getting in terms of solid numbers, right? So you should be able to make a difference either in terms of improving the top line or really kind of helping them improve the bottom line. And by the way, top line means increasing revenues of a business, bottom line essentially helping them improve their profitability. It could be more of cost optimization and saving costs. So that's one focus with which we go into any client space. The second, we are not merely implementationists. We kind of also help them draw up the strategy, and that essentially involves tracking the trends, what is happening, what is changing, and what exactly needs to be done. The third thing, our focus is on digitization. Again, without going into too much of a jargon, what is digitization? It's essentially the process wherein you are replacing a lot of your manual stuff to be done by an automated systemic way. That throws up a lot more data, right? So converting the processes into automated system-driven process is one thing. Really being able to understand the implications of that and being able to leverage that to further enhance your decisions is another. So our focus area in terms of digitizing and analytics, there is a significant overlap which actually results in better benefits. The last one, our focus has essentially been to be part of this disruptive technology trend that's out there, cloud. While cloud has been there for some time, its adoption in the analytics world and kind of moving completely onto cloud for analytics is something that's really picked up pace. And from a recent survey, we understand at least 70 to 80% of the clients moving their analytics. There was always this trend of certain industry sectors moving there, but we see that pretty much everyone across the board, be it even sensitive sectors like healthcare and finance, finally moving on to cloud. So that's something which helps us deliver these solutions much better, our exposure to across the cloud platforms, be it AWS, Azure, or GCP. Now coming to why do companies or decision makers, be it CIOs or CTOs or CEOs, have to invest or are investing in analytics solutions? There are 6 primary reasons the way we kind of look at it from our own experience. One, I briefly touched upon digital transformation and the lot of data that it is throwing up and making value out of that data. Second, mergers and acquisition. Give away an year or so of a slowdown that we have seen with the COVID situation around, there is an increasing trend of mergers and acquisitions happening. So when 2 businesses come in, there is always going to be that additional hunger for data, and data kind of really is at the core of what we do. So that helps us position ourselves and help companies who are getting into this and make better decisions. Third one, data monetization. Well, business intelligence analytics has been there in one form or the other, but what is exactly monetization? Essentially looking at taking the next step in terms of really being able to move to AI, ML, not just kind of deliver insights, but use them as additional revenue generating streams. Use them to actually optimize outcomes, not just predict what will happen, but how do I want the optimal outcome? So that's another area that's kind of taken off big time, which is pushing the analytics at great speed. Modernization, we briefly touched upon cloud. It's all about kind of cutting down on operational expenses, moving on to cloud. And also, as I talked about, the volumes are ever expanding, and the only solution, at least in the near future, from what we can see, is going to be the adoption of cloud. Move on to self-service. The other emerging facet of analytics is moving away from IT-driven solution to essentially saying, yeah, business as an end user can control this process. Right. So when we talk about getting in data, analyzing the data, does it always need an IT guy? No, it can actually be done by the end users. But that doesn't happen with a turn of a button or just pressing a switch, right? So there has to be investments going to happen to really enable that. So that's another area where a lot of analytics focus and spend is happening. The last one, very key trend is regulatory compliance. With the explosion of data, how you actually care for your data, how you actually are able to really comply to all the requirements in terms of safeguarding the data. Just to call out one specific regulation, there are a lot of countries which have their own framework to really help manage the PII data, or personally identifiable information. So not just having the data, being able to protect it and use it properly is another big challenge, and that is driving a lot of people to invest more in this space. So with that background, let's now come down to the question of what is data. Again, a very silly question, but yeah, there are different ways to interpret it. The earliest way of looking at it is data is always a number, right? So initially, the thought process behind saying I'm dealing with data is I'm doing number crunching. Both were used as synonymous. But from there on, we started looking at data that can define anything about a person, object, or a process. So therein started bringing in some of the textual data. Okay, I'm talking to 200 students. Great, that's one number. I can always say I'm talking to 200 students from CDAC who are from computer science branch or engineering from mechanical branch or whatever it is. Started introducing a lot more stuff there. Right? That's exactly what we are talking about, additional elements other than just that 200, 300. So that analysis of looking at number from a contextual perspective, that's the second phase. And as we move, we are now kind of talking about anything that can relay information as data. And a good example of that is a lot of the unstructured data that we see around. Call your photo, a video, or that voice message. All of these are data in this world, right? So they are, in one sense or the other, ultimately they can be converted, decoded into a format from where you can draw some intelligence from it. So that's an ever evolving definition, but for us, we will go with the last line there. They are atoms of decision making and are the smallest unit of factual information that can help us drive decision. With that commonly agreed definition, let's look at understanding why it is important and why it is exploding. Data is important because, one, as we spoke about, you will have to make decisions at some point of time, and making a decision on hunch is not always going to be successful, right? So you have to base it on some logic, and data is the best way to really be able to deliver that logic. And this data that we are seeing around is exploding or increasing in volume, velocity for a lot of different reasons. A few things to call out is the explosion of e-commerce around us. Pretty sure most of us on this call would have actually transacted on one or the other of these e-commerce sites, right? So have you really seen this before? Maybe 8 years back, 10 years back? Not. So these are throwing in a lot of data into the ecosystem that actually can be utilized and used. And just an important, maybe off track, do you know why Airtel came up with the idea of payment bank? It's essentially to kind of piggyback on all the customer data that they have and then kind of create a new data stream. So where did all this deviation and new addition of services and other stuff come in? It's essentially the power of data that they were holding that were helping them kind of move on and create this stuff. Similarly, look at what digitization has done. So what it has done is, as you reduce on the manual processes, you made them computerized, you made them kind of rally around as IT systems. They have started churning out a lot more data. So that's another reason why we are really having all of this additional data coming in. Third, All of us definitely have used our phones and other stuff, but we are also looking now at connected devices, right? Be it automobiles, cars, connected cars. Yeah, we have a lot of appliances, be it an AC or be it any other stuff that we have at home. These days, all of them can be connected and they kind of keep continuously generating data. So that kind of is adding on to this additional data and volumes that we are seeing. Finally, as we said, it's no more about number or structured data, right? So a lot of the data which we would have otherwise passed off as not relevant, as an example, we said images, videos, all of that is now kind of coming into the realms of analytics and data. So that's again causing these volumes to grow. Now, what is this really kind of leading us into this, all these data challenges and other stuff that we have to deal with because of this data explosion? How do we manage to kind of store this data? There's the typical approach of saying, I'll put it on a desktop computer or I'll put it on a server in my data center. We have gone past all of that. So therein comes in the cloud platforms to really tide over that. We talked about regulatory compliance needs, the controls that we'll have to adhere. So how do we kind of take that challenge head on? Therein comes in a lot of the data governance tools, which really can keep an hawk eye on what we are doing with the data, how the data is moving across in the entire ecosystem. Then comes the data value. While I get a lot of data, does it all make sense? May not be, right? So you will essentially have to upfront decide what is useful and what is not. So some of you might have understood or read through about the Pareto rule. So the 80-20 rule, what we are talking about, right? So a lot of the data that we generate may not necessarily be useful. And just 20% might really be what it actually boils down into that will help us make those decisions. So being able to understand that value upfront, which is what a lot of the data exploration tools allow you to do, figure out what is relevant, what is not relevant upfront, is kind of helping us tide over and go after the data that actually matters. Finally, it also brings the challenge of being able to process the data in time to really make any sense. I cannot take data and kind of process it for a month and then realize the decision that I have kind of providing is already a decision that would have taken place in the past. So it's essentially important to be able to be in a position to deliver those insights quickly. And that's possible through streaming real-time capabilities that are coming in these days. So if I have to put in 3 bullet points, what this data evolution has translated into. Moved away from traditional data where we were always talking about structured data stored in databases in organized repositories like a data warehouse. There it has moved into what we call as big data, which could handle structured as well as unstructured data. And it was stored in file or object-based storage. So for those of you who are conversant with Hadoop, the likes of HDFS. And again, the storage, it kind of expanded from being only constrained to relational database into more of the file-based formats in a data lake, columnar storage, NoSQL databases. So that list of where you can store the data has been expanded. Where are we heading to? Is big data the end of what we are seeing? No. We are recently coming up with a new paradigm. I don't know how many of you have heard about this already. Concept of wide data. What does that mean? Well, long data, lots of records is useful, but being able to understand few data, small rows of data, but lot more attributes about the data will help me make better decisions, right? So I can come to CDAC, meet each and everyone, and I can come away saying, yeah, this is great. Or I can talk to a sample of 5 or 6 people, spend a couple of hours with them, and then maybe gain better insights of what CDAC is actually offering to the students, right? How they are really learning or shaping it. So that's the change that we're currently seeing. It's in transition state, not widely adopted as yet, but the next trend could pretty much, if you're talking about 2 years, 3 years down the road, focus can potentially be on wide data, where the question is about how many more additional attributes of a given piece of information can I take in and analyze, right? So that's potentially the way forward. Be on the lookout, and pretty much would like to come back and talk about this if given an opportunity down the road. Then moving on to when we are talking about data, whether it is big data, small data, wide data, there are 5 key things that we need to look out and understand because this is going to really help us come up with the right solutions in terms of how we can actually process the data, store the data, consume the data, and deliver our insights. First of which is volume. Obviously, it refers to the size of the data. Again, why is it important? We spoke about the factor of IoT devices. So the volumes are ever increasing. If the data is small, I'm probably going to choose a typical relational based system to really be able to process and deliver these insights. Large data with a lot of this unstructured data, I'll have to look at something like a data lake, and I'll have to look at maybe a Python or R-based language to be able to understand and implement AI and ML on top of it to deliver those insights. The second part is velocity, is essentially the speed at which the data is getting generated, right? So that's another important aspect that goes into deciding how quickly can I process the data, can I really deliver those insights in time for it to actually make a difference to anyone. Couple of examples there. We are kind of talking about autonomous cars, right? So the simple kilometer drive by an autonomous car throws up an enormous amount of information, right? Why is this important, right? So this is important because that analysis of that data is what is essentially making a difference to how the future technology and the technology improvements are happening. So the reason we need to study velocity of the data is again twofold. One, it helps us understand how we can tackle the problem of processing. Okay. And how we can actually consume the data for insights. Third one is a variety of data. We have spoken enough about it. Structured. We'll kind of pass that. So being able to understand what is the structure of the data will also help us adopt the right methods to be able to consume the data. What is veracity? Veracity is the data really reliable? I can have lots of data, but it's all junk. So I really need to figure out if the data is coming in from the right place, and I really can make use of it and deliver some useful insights. So whenever I'm dealing about data, the questions I'll ask is, what is the source? Where is it coming from? Can I really track the lineage from where it has come in so that I can be certain that it is good data, quality data? Finally, value. We spoke briefly about that 80-20 rule. Lots of data doesn't always mean great decision making. It's that piece of information which really makes an impact that I need to identify and then kind of drill down onto that particular data to be able to really add value. So whenever you're talking about data or a data system, be it in the world of data engineering, data warehousing, or data analytics, it's important to really understand the data and these 5 attributes. Moving on to how do you actually look at data from an analytical lens? If I am looking at data, there could be 2 perspectives. A statistical view, wherein I say, yeah, my data can be looked at from what is called out as quantifiable data and what is qualitative data. Essentially, something that I can kind of put it in numbers, that's going to be what we are calling as quantitative. Qualitative is something that I cannot call out by numbers, but I can still assign a label or attribute to it. Right? So that's one way of looking at data. The other way of looking at data is figure out what is a fact, what is a dimension. A fact is a number that I'm interested in, it conveys something. To go back to one of the earlier examples, sales. How much sales I'm able to achieve, how many students I'm able to enroll is a number that actually measures the overall success, right? And then the dimension comes in through the other angle that I spoke about. How many people have a background in engineering, right? How many people have actually kind of taken on analytics or big data as a preferred subject in their course. So those are the other things that can provide me additional inputs. So that's another way of looking at data, statistical view and analytical view. So each data element that you are talking about will obviously fall into each of those buckets. So this is not either there or here. The purpose for which you will do this classification is slightly different. When you're looking at a statistical breakdown, that's what will feed into any of your AI and ML related solution. When you're talking about analytical view, this is what will go down into your business intelligence, or for that matter, any of the prescriptive or the descriptive kind of solutions. Right. So jumping on to the second one, what is a decision support system and why should we look and understand it? The decision support system is nothing but a computer-based system that helps us make those decisions that we are talking about based on the data that is stored there. It has three components. One is a data repository, can be in different forms, different shapes. Just to call out something that you could relate to, a data warehouse or a data lake. Then how do you process it? Obviously, there are a lot of different changing paradigms, but again, to go back to something that you could have probably correlate to is ETL or ELT, and then you have cluster computing. Hopefully, some of you might have heard of Spark or things like that. So those are the various ways in which you process the data. And then data consumption, which are the set of tools that actually deliver the insights, and which is our focus area as we step on to the next section. So why do we need it? It's essentially because your transactional systems cannot really deliver all the insights because of constraints that are imposed on a transactional system. That is one. The second, you always need data to be brought together, integrated to be really able to deliver some insights. For example, think about a customer who has, let's say, a banking customer. Let's say he has a credit card, he has a debit card, and he also has a loan. Three pieces of information lying around in three different systems. And I go back to the guy and say, yeah, this customer could potentially be leaving us. Tell me what is the overall business he does with us so that we can try our hand at try and retaining. To be able to answer this question, you need all of the data at one place. So a typical example of why you need to integrate data. And then third, you do need standardization, right? So each person can go in, look at the data and interpret. You always have that statement, statistics lies and damn lies, right? So unless you have a standard way of implementing and understanding data, there is always going to be different outcomes of the same data set, which is where standardization and bringing in the consistency into the data is possible with a decision support system. So again, a bit of a comic relief there from all the monologue that I'm kind of giving. Guy in the middle, yeah, you can turn out to be that guy pulling off your hair trying to make decisions, or you could have a decision system which can really help you make all those decisions and leave your hair intact, right? So any question that you have, the decision support system can be molded to be able to provide those answers. So we spoke about three layers there, data repository, data processing, data consumption, and what does it mean to the overall decision support system. I'll probably kind of move quickly from here. The understanding is you need to have a storage area, which is the data repository, processing layer, which can actually do the data cleansing and bringing some order to the data, and finally consumption, which can actually provide you those analytical insights that we all want to know. Right, so this is probably the most important one to ensure that we're all on the same page. Do these three terms mean the same? Business intelligence, data analytics, data science? Yes or no? Yes, because there is an overlap between business intelligence and data analytics and data science. But when we say overlap, does that really mean there's one and the same thing? No, because that overlap is only to a certain extent. So there is always something beyond that overlap area. So we'll try and understand what is that overlap between the different pieces and why we should actually have all of them. It's not like I have a business intelligence system, so I don't need data analytics, or I've become matured enough, so I am kind of running my data science and I have a team of scientists, so I don't need business intelligence or analytics. So they are there for its purpose. Let's try and figure out what that is. Business intelligence, again, a bit of a bookish definition there and a typical process around it, but few key callouts. It always talks about historical or current data. So it's always backward looking or looking at the data that is coming in now. It doesn't really have a forward looking present. Second, it presents the information to improve decision making. So it doesn't create or alter the data. It only kind of presents the data in a different manner so that the information is actionable. Third, it always provides you a rear view mirror. So what has happened in the past, if I want to explain something, and if I want to monitor a process and its outcome, that is where business intelligence helps. Next one, it really helps me identify the choking points in a business. Let's say I have built up a business and all my sales guys are going there in the field getting a lot of new business, but I don't have the real ability to service all of those customers. An example, right? Lots of newer car models are coming in. If you have looked at probably Mahindra these days, a lot of interesting cars and SUVs that they are releasing into the market. You go and look at what is the waiting period, 6 months, 8 months, right? Obviously, there is a reason for that. One, they are generating so much interest with the good product, with the extractive marketing, but they are not able to really keep pace with the demand and line up their manufacturing. There could be other reasons. We all keep talking about this, semiconductor issues, and so on. But just to give you an example of why you essentially need to identify bottlenecks. And moving on, they also give you an alert kind of a system, right? If you are really able to know them as it happens, instead of having to wait for the end of the month to figure out something has gone wrong. So those alerts which can come in real time as things happen can really help you course correct that much more quickly. So these are the objectives why you would want to have a business intelligence system. Now let's take a look at what analytics does and why it really needs to be there even when you're having your business intelligence system well set up. First one is the data preparation. In business intelligence, we talked about essentially kind of taking the data and presenting it. In analytics, you do some pre-processing so that you can kind of start giving or delivering those insights without just basing on the historical data. A quick example. So if you are really looking at something that we can relate to, I am pretty sure most of you are on Swiggy, and they have a lot of these options or schemes where you can get away without paying for delivery charges, right? If you notice it or not, every time your membership is going to kind of run down, they come up and say, yeah, you have saved so much. You paid $300 for this service. Over this period, you save 1,000, right? So how are they doing this? Really being able to look at that data, prepare it in a certain way, and able to conclude, compare those two numbers and tell you, first, you are better off making a renewal of your subscription. Second, we are talking about data not just from a reporting perspective, but being able to explore it to really identify whether that data makes sense and it is quality. In business intelligence systems, you don't really question the data that is coming in from source. It says X number, it is X number. But in data analytics world, you always look at it. Is this an exceptional number? It happens once in blue moon. So should I actually be considering it for a decision, or I kind of throw it out as an outlier? That's essentially what data exploration helps you understand. Take out those anomalies, whether that are intended or unintended, that kind of makes the data lot more smooth, less noisy, if you have to kind of use the statistical language. Then we are talking about mining, essentially understand the patterns in between the data, right? So again, let's go back this time away from Swiggy. I'm in a mood for a lot of food coming into the weekend. So let's talk about Big Basket. You go back and open up a Big Basket app, right? You would have done a lot of shopping, and he will come back and say, based on your previous purchases, you might be interested in this product which is getting at a discount price, right? So that's essentially the power of being able to mine the data and essentially being able to tell there are certain patterns which can help you make a better decision. Then looking on to prediction, it's obviously the next logical step. Once I've understood the pattern, can I really figure out what happens next? I can take a much more educated guess rather than throwing a blind dart. That's what prediction capabilities allows. In a sense, there is a bit of an overlap between mining techniques and prediction. That's probably a topic for a different time, but essentially the objective behind mining is to find the patterns. Prediction is essentially to be able to take it forward and tell what will happen. The last part is about improve. It's not just about saying, yeah, this is what will likely happen. How can I improve that likely happen to definitely will happen, or likely happening outcome is not the best one that I would want, and how can I make that or change that into something that's more favorable for me? That's the process of improvement we are talking about. If I know all of those stuff, I can definitely move in that direction of improving. So you, at the end of the day, if you compare those two, business intelligence is more of a rear view mirror. It's telling you what has happened. It can possibly also explain why something has happened. Analytics takes over from where a business intelligence stops, why something has happened, and then kind of move on and say this is likely to happen. And if you do this, the outcome could be even better than what it is being predicted or projected. Moving on to data science. So herein, we are talking about taking off again from where analytics left off. Analytics kind of told you what is likely to happen, which it predicted an outcome, and possibly said if you do this, it could improve. From there on, data science takes over and starts to kind of use the same data and additional analysis to really learn from it and optimize the outcome. Okay, if I know why a particular customer has bought a product or not bought a product, right, I can, with the help of analytics, say he is not likely to buy your next product, or next month he is not going to purchase this. But with data science and the help of AI or ML or cognitive technologies that we are talking about, we can as well go back and tell, if you do A, B, C, you will likely have the customer come back and buy this, right? What could that A, B, C be? It could be a promotional campaign. For example, I am a fence sitter. I would probably buy this product if it comes at the right price, but otherwise I will not go and buy it. So the learning from the data actually helps us conclude that this guy is someone who might be tempted if there is additional incentive, otherwise he will not. So data science takes the analytics forward from just being able to predict, kind of transforming that prediction into something which actually helps us with a better outcome. Data science also probably people will kind of tend to equate with AI and ML, not exactly the same, because as we said, there is an overlap. And AI and ML is more of set of techniques rather than actually calling it out as a topic by itself. So that's could kind of lead to a huge uproar with a lot of data scientists around. But again, AI and ML is essentially a set of techniques. If you want to call it as advanced techniques, as some do, that is fine, which helps you take the baton forward from analytics, predictive analytics, into prescriptive analytics and what we call cognitive analytics. Right, so we talked about all of those differences. So that's summarized in a table. I'll not go word by word, but if a lot of that text is really confusing, let's come down and look at this. So you see that blue circle represents business intelligence, red data analytics, and the green is data science. As you can clearly see, there is a fair amount of overlap between each of those areas, which is what causes all the confusion. Are these the same or different? Again, if I have to really talk about the differences in 4 major parameters. 1, what kind of data they rely upon to deliver those insights. When it comes down to business intelligence, it's always structured data. When it comes to analytics, it kind of makes use of all 3 data, but more focused towards structured data. When it comes down to AI ML, it uses all 3 again, but the focus is on unstructured data. Second, how and where does this data for carrying out these data analysis or data science activities reside? Business intelligence relies more on relational-based data systems, typically a data mart, ODS, or relational-based data warehouses. In the case of analytics, the data always comes in from data warehouse, sometimes file-based data lakes as well. When it comes down to data science, most of the data required for it is kind of stored and accessed from data lake. Third difference, how do you actually communicate the findings that you are able to kind of come up with on analyzing this data? Business intelligence uses techniques like reports, scorecards, dashboards, and visualization. Again, a fair amount of overlap there when it comes to analytics, but one other additional way of delivering those insights with analytics is what we call as modeling. And then when it comes down to data science, most of those things that you communicate are using ML algorithms. Finally, in terms of the analytics, there is a classification on how the data analytics evolves from the lowest level to the highest level. We'll touch upon it a bit, but to kind of complete this slide, business intelligence addresses descriptive and diagnostic, which we called as backward looking or a rear view mirror. Where it comes down to analytics, it looks at explaining why something happened, which is diagnostic, and predicting what will happen, which is forward looking. And when it comes down to data science, the focus is essentially to tell what should happen and how I can learn to make those outcomes really happen, which is prescriptive and cognitive. So hopefully this kind of gets us all on a common page on what these three terms mean. So we'll then jump on to kind of deep diving a bit more into business intelligence and data analytics topics by themselves. So business intelligence definition, all of that said, so how do I actually implement it? It's a 5-step process. First of all, I'll have to figure out where the data is, which we are calling as data repository. And then I have to make a BI tool or platform selection. There are different categories of tools, enterprise BI tools, self-service BI tools. All of us really dictate how you are going to implement the same concept. So the difference is more in implementation, not the outcome. So we'll kind of not go too deep into what these enterprise class or self-service class platforms mean. Just sufficient to understand that the tool selection is an important process, because that is going to determine how you will implement the how of it, not the outcome of it. Then a semantic layer. When you look at a database with all those tables, right, you cannot really make a lot of information that makes sense. But if someone actually can pull all of that data and put that more into an Excel and call those columns out with more a business-friendly name, then it starts ringing bells in it, right? So we can correlate to it better. Semantic layer is essentially that layer which helps hide the technical complexity behind the storage layer and expose it in more user-friendly format. Then obviously content development, we spoke about different ways of delivering the data. And then we come on to how do you actually distribute this content, right? So ultimately it has to be kind of delivered to the guys who are the decision makers. How do I set up those reports? How do I refresh them on time? And how do I ensure it reaches the required or end user? So as I said, I will pass on this, but broadly enterprise BI is something that's more centralized in an organization. So the tooling choices are all kind of made so that across the enterprise, there is one tool of choice, which is essentially managed at a central level, so that everyone has access to data, but they're using a standardized procedure and standardized way of accessing the data. Self-service BI essentially allows the end users a bit of leeway in how they access the data. They want to do more processing of the data that they are accessing, and how they can kind of tweak the reports, either already pre-built or built on their own. So that's the difference in terms of how enterprise and self-service class BI tools stand up. The second way of looking at this is, what do these tools actually deliver? One is it provides an operational information, which is what a lot of these reports are, right? How many students join, right? How many have attended an exam? I need to know, because I have to really ensure I'm able to reach out, give them a warning notice. No, you have not attended, only so much of time to attend, things like that. Then there is always the different way of approaching BI, which is to look at it more from a strategic perspective. So which is where the overlap with the analytics is coming in. So here the questions that are intended to be answered is, okay, so what will happen, and whatever has happened, how can I change that? Which the newer way or the trend that is happening ultimately, moving from BI into strategy BI, where you will start seeing the difference between BI get even more blurred as you move along. So I spoke about a semantic or a business modeling layer that hides the complexity of the data and makes it easy to interpret. So this is a bit of a lowdown on what that business modeling layer actually contains. We have looked at some of these metrics, essentially calling out dimensions, hierarchies, relationships all together as one. It's nothing but how I can view a data point. To go back to our same example of students and exam, I can say X number of students have taken the exam, or I can kind of extend that statement by saying, from this branch have kind of come in and attended the exam. The branch of students I'm mentioning there is essentially the dimension. I can add another thing to it saying, yeah, these people have attended term 1 exams, term 2 exams, term 3. So I'm introducing the concept of time there. So time could be another dimension. Similarly, hierarchy is a way you can actually roll up your numbers. Let's take the example of a city address, right? So if you are nobody, you're not an Ambani, neither am I. So if you're looking at reaching out to someone and you take their address, so how does it break down? So you will essentially start off saying, okay, this guy is in, let's say, Maharashtra, or Telangana, or wherever it is. Then you'll say he is there in Pune. And then you will say, yeah, he's in this particular area and this particular college and this particular class and section and so on, right? So this is essentially forming an hierarchical pattern wherein you can say, I can figure out all the guys who are there in Maharashtra. I can figure out all the guys who are there in Pune. I can figure out all the guys who are attending CDAC, all the guys in CDAC who are attending this particular course. That's all that we are talking about hierarchies. The second set that we spoke about, facts or measures, essentially is how we are numerically quantifying and measuring something. So there are different variants to it. One of it is metrics. So a raw number, like if I say sales, is a fact or a measure. When I say metrics, I can say sales as a percentage of last year. So our month-on-month sales or quarter-on-quarter sales. So what am I there giving? It's essentially the growth or the difference in terms of what was there last and what is there now. So now a measure has turned into a metric. And then what is a KPI? KPI is essentially something that I really base my performance and judge my performance on, right? So let's say in the case of, again, to go back to EXUSIA. For us, it could be a KPI like net profit. I can take a lot of business, but I always want to operate at a certain level of profitability, right? So that net profitability, which is profit divided by sales, profit divided by sales into whatever percentage, is the single number that defines whether I'm successful or not, right? So I say if I'm able to achieve greater than 20% of profitability, then I am really kind of succeeding in my mission. That's how you would kind of translate a raw measure into metrics and KPIs. Moving on quickly past these two slides, how can you present the data? It can be tabular reports, yeah, lots of information, but it makes sense to present it in a data when you do want to look at the granular data. For example, I want to identify the top 10 students in a class. Would it make sense to put a graph there? No. I can kind of put those names in there, their marks, and it makes it a lot more clear. Visualizations. When can I kind of look at presenting the data? We always say visual is much more appealing and can convey the information. But again, there are certain cases where I really need to use that to make a lot more sense. In this particular graphic, if I'm looking at the students, I want to understand their birthday pattern, right? What I'm essentially doing, some amount of aggregation so that the number of students whose birthdays fall in a month is available, as you can see there. So that kind of gives me a better picture rather than putting a table and say everyone's birthday is XYZ day. It doesn't convey anything to me, right? So that's where you can use visualization techniques. Then you have dashboards and scorecard. Dashboards, again, to relate to it easily, look at it sitting in a driver's seat in a car. What do you see? Lots of things there which quickly tell you whether the car is good enough to drive. You know, yes, the engine is all in good shape. The engine check light has not come in. You look at the fuel tank, you say, yeah, it is there. I can run off. Engine, yeah, it's not overheated. It can pretty much go. So dashboard is pretty much like that. It gives you all the key things to understand the overall health in one shot. Instead of having to go back and check 5 or 10 reports, I can bring in all those KPIs metrics to one place so that at a single shot, I know what is the overall health. And then coming to scorecards. So scorecards is essentially a way of summarizing the data wherein I group all the related things into one place. Again, let's now go back and for a minute talk about cricket. So when you're watching a cricket match, great. But if you are not able to, what's the next best alternative that can tell you what has actually transpired in that match? It's the scorecard, right? So in one sheet, what is it telling? What is the overall batting performance? What is the overall bowling performance, right? Who did well and whatnot. So here it's really able to break down the entire match into those different aspects and able to give you a view on how that performance is against each of those group of activities. So that's what scorecards tend to do. Typically like our report scorecard. At the end of the year, you get a report scorecard, and if your parents have not really looked at it for the entire year, they might be in for a surprise, good way or bad way, if they look at the numbers and figure out that it's pretty much different from what they were expecting, right? So that's again, in a nutshell, a bird's eye view of the entire performance tracked against something that you can call as a goal or target. So as we spoke about, both business intelligence and analytics really drive some kind of analysis, but the techniques are different. With business intelligence, the techniques that you use are filtering the data so that you can focus on a subset of data and look at it minutely. The other way, you can also kind of slice and dice the data. What is slicing? Slicing, again, is essentially taking out one subset of data, right? So again, go back to your own example. So I can look at the entire CDAC community, or I could say I'm interested in only CDAC Pune. So that CDAC Pune becomes one slice in that entire cube that is there. Dicing. Now, dicing is a way of looking at data in a particular different combinations. Now, I have narrowed down on saying I'm interested in the Pune population of the CDAC students. And then I want to look at it, how many of these students are really kind of coming in from a different engineering background or from a non-computer science background. Or I would want to look at how many people have really passed their exams with 75% plus or with less. So those are the things that I can look at and understand by using slicing and dicing techniques. Drill down, drill up, very intuitive, so not much to say. When you have a hierarchy or a path which can kind of take your data from a very high granular level, very aggregated summary level to a low granular level, you tend to use the technique of drill up and drill down. So from an implementation perspective, from a technology perspective, there are different ways how you can implement a BI solution. Again, we'll make a quick pass, but suffices to say business intelligence system are built either on top of relational databases or multidimensional databases, which we call MOLAP or ROLAP. In a few cases, there could also be a combination of those two techniques, and a few vendors are coming up with their own proprietary way in which they organize and query the data. So those are the different approaches. Important to understand it, because when you are making tool choices, this is one of the factors that goes into it. Now, coming to data analytics, the second part, there is again a clear recap here. When we spoke about business intelligence and analytics, we saw there is an overlap. And then we also made that statement where business intelligence and analytics takes over, right? So based on that premise, now let's continue this. So when you kind of look at analytics, the first question comes up is, in real world, does it really help me? Why should I even study it? So let's understand what are the various use cases where it really touches up in our real life. When you kind of have a credit card, or let's say a debit card, at the end of the day, in a month, in a statement, you want to see what all you have performed as transactions, correct? It's historical data, it has already happened, you cannot change anything about it, but you do want to understand what has happened so that you can plan your next month, or you can plan how you are going to pay up your balance or whatever it is. That's one reason why you could look at the descriptive analytics, typically a branch of business intelligence. Second, I want to look at, to get down to the details of why something happened, right? Let's take the case of a telecom company. They all of a sudden start losing customers, right? They can sit back and say, yeah, it's part of the business, I'm losing customers. Or they can come back and say, I need to understand why I lost them, so that going forward, I can arrest that attrition or churn, right? If you have to really explain that, you need to have that old data, and then you need to diagnose that data, which is where a diagnostic analytic kind of techniques come into play. Predictive. Essentially, when you're looking at predictive, right, you want to really stop some catastrophic things from happening, or based on certain things, you want to really understand how the future will hold out for you. An example, in every machine, you have a lot of factories, right? You can wait till the machine actually breaks down, or you can keep monitoring it, track when it was last time, when did it actually fail, and be ahead of the curve. If its cycle is 4 years, the product owner has said, yeah, it fails after 4 years, or it needs a replacement or overhauling after 4 years. I track it ahead of time so that I can essentially kind of figure out at what point I need to really take those steps to ensure it doesn't break down. So case why I will need predictive analytics. Prescriptive analytics. So what can I actually change for a better outcome? Again, let's take this example that we have in the first line, travel and logistic operations. So when you send out something through a courier, right? So there is different ways in which it can go from point A to point B. So if you are really sending it all over the place, the cost could be enormous and it could take a lot of time, which is where some of these techniques really help you identify which is the optimal path. For most of you, again, who are used to e-commerce shopping, right? A lot of times you will see a product coming from Pune to Hyderabad, but it goes to somewhere to Mumbai and then to somewhere and then comes to Hyderabad. And you'll be wondering, why did it happen? There is a reason for it. The reason is from a cost perspective, that's the most optimal way in which they can deliver. And that's essentially being enabled through predictive analytics. Prescriptive analytics. And then we have cognitive analytics, which is essentially learning from things that is happening around it and improving the outcome. We briefly spoke about self-driving cars. Another example that could fall into that place is the likes of Sydney and Cortana that you actually see on your device, right? So again, if you haven't, please go back and check this. So if you ask multiple questions in different ways, the responses after a time will change. It's not like whatever you say, it's like voice response system, you get the same thing. Why is that happening? Because the more questions you ask, it is learning from it. And then next time around, it's able to give a better answer, which is where you need cognitive analytics or cognitive intelligence. So again, from data analytics, how do you implement it? It's again, some people have put 6 or 8 steps, but broadly, there are 5 things that you would do. The first one is bring in the data. Second, identify the right use case and the tools and technologies. And then use these so-called discovery and exploration and mining techniques to be able to identify the right sets based on which you want to build your models or algorithms. Finally, you get down into building your models. In analytics world, models can be built 2 ways. One is statistical mathematical models, wherein it overlaps with data science. And you can also build dimensional models to really be able to decipher and be more informed, in which case it tends to overlap with business intelligence. So the 5 types of analytics, we spoke about it along with use cases. So I'll kind of quickly move on from this. So looking at the entire life cycle, lots of guys, again, campus enthusiasts, people who are stepping in, come back and say, I want to be a data scientist. And this slide is essentially for those. While data science and data scientist is great, it actually builds on what you build with data engineering. So to that extent, data scientist has to kind of be dependent on how the data is being brought in and processed to really start delivering more insights. So the first few steps that you can see are bringing in the data, kind of converting, ingesting them and processing them, and ultimately dropping them into a data repository, which we refer to as a data warehouse, a data lake, or whatever different nomenclature that we have, becomes the starting point for an analytics or a data scientist guy to take over and deliver. Right. So that's essentially how the overall flow happens and the integration between the data layer and the analytics layer. Now, in a real world, how does someone go about implementing it? People tend to kind of look at this as more or less a hierarchical chain, tend to start from descriptive analytics and move up to cognitive analytics. Again, depending on which person you talk to, people kind of put this into overall 3 or 4 phases. I would rather like to believe it's 4 phases. One is where you're just reacting to information coming your way. Second is proactive phase, where you not only kind of understand the numbers, start doing something so that the outcome can change. Third one is where you start optimizing it. I just don't kind of take in the data and say this is going to happen. I want this to happen, and how can I make that happen? Phase 4 is where we talked about cognitive or learning capabilities that come in, so that the system kind of completely disconnects from the human individual, wherein a lot of these automation things to happen. Be it that driverless car that we are talking about, or any other autonomous things, all of that fall into this cognitive analytics or phase 4 learning, self-learning category. So data exploration and data mining. I know I'm hitting close to the time, so slightly pushing ahead. These are 2 different ways in which I can prepare the data and look at the trends before I actually get into modeling. So when a lot of people equate analytics with modeling, don't get fooled into saying, yeah, modeling is the beginning of analytics. So you do have to kind of figure out what is there in the data, you have to at least build out a hypothesis of what do you think are the possible trends that are there and the relationship between the data. That's when you actually get into modeling. So for those initial two things to happen, you tend to use data exploration and data mining techniques. So typically, these are done using SQL queries on a database, or you could use the likes of R and Python on structured or unstructured data to be able to understand it. Or you could then move on to start applying the algorithm-based approach to be able to deliver those. Now, coming on to the last one, which again kind of brings us to the starting point at the door of data science. So what are the techniques that I use in data analysis? In business intelligence, we spoke about filtering, slicing, dicing, blah, blah, blah. But when it comes down to data analysis, a lot of these techniques have a significant overlap, or at least having the need for basic understanding of statistics. Let's look at some of them. Classification. Classification is a way in which you can segregate the data into different classes based on the labels, right? Again, what's an example that we can go? I have all the students there, but I don't have any other information, and I'm asked to kind of pull them into certain groups. Can I use classification there? No. Why? Because I have no label information there. If suppose I'm given along with the student's name, let's say their date of birth, can I then start making an educated guess and put them into different classes? I can, right? Because roughly date birth will tell me which year they passed out and potentially can kind of help me put them into different buckets. So that's how classification works. Cluster analysis typically goes completely against what I said for classification, where I only have numbers. I have no other way in which I can break them down. But I still want to do that. So how can I do it? Let's say there is a random population of customers who are a random population of guys who have gone to a movie. And I then want to figure out who is a diehard movie buff and who has just gone because, yeah, someone else has sponsored a ticket, or just for the sake of it. I can actually take the data, plot it, and then figure out guys who have gone to the movie maybe twice or thrice in a month. They're all kind of grouped or clustered together at one place when I point it, right? Because they have multiple dots around it. And then people who have gone only once, they tend to get scattered in a different place. So using cluster analysis, when I don't have any other way of segregating, I can just use the pure data points and then still figure out how they are kind of associated, right? So that's a way you would use cluster analysis. Regression techniques, pretty much most of you should have seen this, how two variables can kind of get related so that we can have a equation form to understand how A will change if B is kind of going to get changed. So the relationship between a dependent and independent variable and how they perform is what you can kind of figure out using regression. For example, if I can actually tell you the number of units I sold, and if I tell you the profitability I have per unit, can you kind of figure out what would be my profit? You should, right? If the number is X, yeah, it's going to be profit is going to be that into this number. If I only have the sale number, I always have the per unit profits. I should be able to overall figure out what would be my profit. So that is where you have one missing variable, but you have the ability to predict because the relationship between those two is consistent. Time series analysis is essentially a way of figuring out what has happened over a time and then being able to project that going forward. Again, a typical example I always talk about is weather, right? So when I am actually predicting the weather, I can kind of depend on what time of the year it is, and then go back and say last year, yeah, between November 1st, or rather June 1st and June 5th is when monsoon started in my place. I can use that as the base and then figure out if there are any other adjustments to be made and conclude this year when it is going to start, right? Roughly, obviously, those additional factors that we are talking about could be the information I'm going to track through the satellites, when, if there are cyclones happening and so on and so forth. But broadly, the time trend gives me an idea to forecast. Then you have something called association rules. Again, there is a different way in which you can attempt what we call as cluster analysis using association rules. This is to kind of put objects that are all related, but that relationship is not clearly evident. One example from real life is your market basket analysis. So if you go back and look at some of the predictions, to my favorite example of food app like Swiggy or Big Basket, right? They understand what combination of products you are able to purchase, and then they are able to kind of make that as a rule. If this guy comes in and the first of month, he's going to buy yes, rice, oil, dal, blah, blah, blah. If this guy is going to come and purchase at the end of the month, he's going to probably buy a shampoo or soap or things like that. So that's the kind of patterns that can be understood by using these association rules. Last one that we'll touch upon, these are not just the only techniques, but something that you would kind of cross paths more frequently. Factor analysis. Factor analysis is essentially a way of breaking down lots of attributes into something that would start making sense by grouping them together, right? So if you have 10, 15, 20 attributes, first, can you really understand how each of them is related or impacted? You may not be. Therein, you start going and grouping those together. A good example is typically how car sales or car comparisons happen. So if you have looked at any car reviews, right, they tend to kind of break down into, okay, what are the internal features or how plush is the interior of the car? And they'll come back into looking at the core engine mechanics. What's the CC, what's the BHP, what is the 0 to 100 kilometers acceleration time, and so on. So that's the second bucket. They're not going to break that down into further small stuff. And then they'll come back and say, yeah, luxury items. So do I have panoramic sunroof? Do I have dual zone AC and so on? So that's a way where you're kind of breaking down all the features, putting them into manageable buckets, reducing them into smaller groups, and then kind of coming up with a decision or a finding based on that. So that's how a factor analysis works, reducing innumerable attributes or dimensions into manageable stuff, and then being able to conclude or provide a decision. So in the interest of time, I'll probably jump onto the last one. I'll give the last couple of slides, Miss. Moving on to what are the options that actually are there if you get onto the data field. Again, no brainer. We spoke about data analyst and data scientist. Is that all? No, you have something called a data architect, which closely relates to how you kind of manage and build out your data repositories. So that's one part where you can understand the interrelationship between the source system, where you store the data, how you process the data, and so on and so forth. Then comes the other role closely associated to data architect, which is data modeler. Okay, I need to store this data. Which table I will store? How are the two different tables related, right? How do I actually kind of build them and logically implement all those relationships? What is it that will take for this to be translated and implemented in a physical database? So that's essentially what a typical data modeler does. And then you move on to data engineer. He is a guy who is essentially going to do most of the heavy lifting in terms of processing the data. Again, for some of you who are kind of interested in this, let me also kind of rewind it a bit. Earlier, you used to call it as data integration specialist, ETL specialist. Yes, there are minute differences between that and data engineer, but by and large, all of that falls under one bucket, which is data engineering or data processing specialist. The differences there could be in terms of what additionally do you do beyond just processing. There are things like how you will schedule the data, how will you manage the interdependencies of the data. That is where a data engineer role is considered to be evolving and all-encompassing. So if you have to really call out a superset of all the data processing skills, that role is data engineer, and probably somewhere down that will be ETL developer and so on. So that's another path. The focus here will be for the likes of you, what does it take to get into this? Things like Python or Scala and understanding computing framework like Spark is what gets you on this path. Then you have a BI developer, in some parlance also called a business analyst, who takes the data, understands the business, and kind of tries to answer those business questions using the data, using typical tools. Those could be rollup, molap tools, or your visualization standard reporting tools. So that's a path where you would need a significant amount of business understanding, and it doesn't really need a lot of hardcore programming tools, but yeah, you would still need to understand databases and SQL, or for that matter, MDX, because the data can ultimately be there stored in those relational or multidimensional cubes. So that's another path. And then you have the typical data analyst, which goes beyond just what a BI developer does. A couple of additional things there is: one, a deeper understanding of the business; two, again, an understanding of what that entire data is, data quality, being able to understand the nuances in terms of the relationships, the patterns that we spoke about. And therein also comes the additional ability to be able to understand and govern the data assets, right? So that's essentially what would get you on the path of a data analyst. Data scientist, again, more focused on what we called as prescriptive or cognitive stuff. So this one will need a very, very deep understanding of statistics and maths. The reason I did not want to dwell too much into data science in this session is essentially because without basic understanding of statistics and math, it will be completely over the head. So we can probably do that separately, but yeah, go back to the point that we are talking about. The data scientists will need a deep statistical and maths background. And then apart from all the other things that a data analyst would need, a lot more understanding of computational frameworks, right? So again, AI and ML, while it is easy to have a one-line code invoking an algorithm, it's also important to understand why that algorithm needs to be selected, which is where you need to have a much better understanding. You use the likes of Python, yeah, it will go and say, yeah, you want to use a linear regression, you want to use a decision tree, great. But what makes you select that model? That's essentially at the crux of what a data scientist does, being able to understand and apply the right kind of techniques, and within those techniques, the right algorithm. Okay, so that's in a nutshell what I wanted to kind of talk to you about. Hopefully, this kind of gives you a fair idea of the different aspects of understanding, appreciating, and using data for decision making. I'll stop here. I know we are a bit over time. If there is interest to continue, we'll hang around for a few minutes to take in any questions. Hey, Keshav, if there are no questions, probably we can call it wraps here. But I'm open to staying back for a while longer if anyone wants to have a chat and kind of dive into anything that we spoke.
Students, any questions from your side?
So if possible, can you share the PPT with us?
Yeah, I believe this session is being recorded, so you should probably be able to go through that. Pretty much open to sharing the content, Keshav, if you want to go ahead and provide it to the group.
Srini, we have a question. The question is mentioned in the chat box. How much importance is given to machine learning?
Yeah, machine learning, as I said, is definitely important both in analytics and data science field. But again, it builds on the data that is processed. So it's, I would say, a two-step process. Once understanding the data. Second, again, fairly clear clarity on what the problem statement is. As I said, it's not all about invoking an algorithm. Thanks to a lot of the machine learning libraries that are out there, invoking an algorithm is a one-line code. But having said that, to be able to understand this is the algorithm I need to invoke, you would need to have a much better understanding of the data, which takes you back to data engineering. That's one. Second, you also need to kind of break down what those algorithms themselves are, which takes you back into statistics and mathematics. So yeah, machine learning is important, but if that is the path you want to go, I would definitely advocate looking at two prior steps to that, picking up on statistics and mathematics, understanding the core concepts of data engineering. Okay, so looking at a couple of other questions, what is important aspect on which freshers make attention? So to me, two things from a fresher perspective. data engineering and data analytics also needs programming skills. So a lot of people kind of think that this is pretty much something that they can do without really learning programming. So the first aspect I would kind of ask you to emphasize on is building some core programming skills. Ideally, R and Python is great, but even if you kind of have strong Java or C programming skills, it shouldn't be difficult to pick up more of these analytical programming languages. That's one. Second is definitely the databases. While databases are evolving and will evolve, RDBMS, NoSQL, columnar, whatever it is building up strong SQL fundamentals to be able to query a data repository, because SQL is going to be the industry standard and will stay the industry standard. The first thing that you will encounter with data is being able to pull out the data, right? So that would need database and SQL skills. I would say those are the two things and a fresher will have to kind of pay attention to. The next question now, what job profiles would an analyst or a fresher look at? So for freshers, I'd definitely say there are two paths. You can start off if you have that deep programming expertise somewhere in data engineer and can kind of make that quick transition into the other roles. Data architect and data modeler that I called out there probably will need a lot more experience, because there are far too many things that actually come through judgment, and it's not like science where you can say, yeah, I'm putting in a formula. But something that's purely dependent on programming skills or heavily dependent on programming skills is data engineering. So that could be a good start. The second place could be again starting off as a BI developer or data analyst. Probably a BI developer is the starting point. From there, you can get into data analyst. But for those, don't think I'm kind of trying to disappoint you. Anyone interested in data science, do build up those fundamentals. It's not that people passing out from college cannot aspire for that, but you do need that strong fundamentals in those two areas I reiterated to be successful there. So that's the next question. What type of tools are majorly used in data analytics like SQL, Python? So there are three categories there. One is what we call as visualization or reporting tools. That's one where you can put in the likes of Power BI, Tableau, Cognos, and all of this stuff into that bucket. So that is more of visual analytics. The second one is more driven through the programming skills. You have already mentioned there, SQL, Python. That's the second set of tools. If you are specifically looking among them, what best? SQL, Python for sure. And then if you want to add R to that, would be good. R and Scala, that would be good. The third one essentially is the last one, the algorithms, which boils down to understanding a bit more about statistics and mathematics and getting there. So those are the three different ways. Again, boils down to which particular part of those bottom three roles that I spoke about do you want to target. Based on that, you should really be able to pick up that. What key difference between business intelligence and data analytics? Right. So quickly recap from that slide what we said. Business intelligence does not really do anything with data. It just interprets the data, and it interprets the data that's more of already produced, whether it is historical or current data. Whereas data analytics does kind of prepare the data so that it can start interpreting the results in a better way. And while it always kind of goes back and uses the historical and current data, it's able to predict some of the future. So it's not generating the data, but it's able to predict the future data based on that. That's essentially the difference. And again, we spoke about the kind of data that is amenable to this kind of analysis, the tools, that's all separate. But from an overall objective perspective, business intelligence, look back, understand what happened. Data analysis, look back, understand what happened, and then see what can happen in the future. The next question, what are the other skills we must focus on learning after this DBBA course for pursuing a career in data analysis and ML? Thought I briefly spoke about that. I'll repeat the same thing. Programming languages like Python, R, SQL, and again, understanding some amount of databases, then getting on to a decent background of statistics and mathematics. Will data science replace business intelligence? Well, up in the air for anyone, but as far as I can see, there is a lot more convergence happening already in terms of tools between business intelligence and analytics. So it would possibly be like business intelligence can become history at some point of time. But the distinction between business intelligence and data science is far too much for them to replace each other. I would like to think those two will still be required separately. What kind of projects will be better for our resume to apply for these roles? I think we spoke about it, starting with the data engineer or BI developer. Which different technologies are using in industries for data analysis? We touched upon it. Generally, on which tools do freshers work? We spoke about it, and I will repeat this one more time because I want this point to sink in. Data analytics is not necessarily giving up on programming skills. So even if you want to go into data analytics, data engineering, do build up strong programming skills in SQL, Python, at least to begin with, before you get onto those UI-based tools. What kind of project should we focus on for data engineering and data science? Well, your academic projects I know can be pretty brief, but I would definitely suggest you to look at something that will touch upon at least two of those four areas. What are I talked about business intelligence, data analytics, and data science. I will add data engineering to that mix. So your project, I think you should look to add at least two of those four and demonstrate that you understand at least two of those four. As freshers, what kind of projects we should go for to improve our resume? I just kind of spoke about that. And again, very clearly from my experience with CDAC, I can tell you a good understanding of basic programming with database skills should stand you in a good place for any company that's recruiting for analytics. I definitely call those two out. Will getting into ETL process be helpful for data science? For sure. Again, the more fancier term, probably data engineering would kind of make more heads roll. So I'd call that, yes, developing a good understanding of data engineering will be helpful as a stepping stone for data science. Which one is more important, R or Python? Again, don't get me wrong, but looking at actual industry adoption, Python has far outpaced R. I would definitely put my money on Python, but that's my personal 2 cents. Okay, a lot more coming up. I'll probably go on for 5 minutes, and if I'm not able to take anything, you can definitely reach me offline. How to choose algorithm for data? This is main skills required. So how to improve the skill? What are the key practices? Choosing the data for algorithms is like, again, saying, don't get me wrong, like starting your lunch with somewhere in the second or third course. So if you have to choose the algorithms, you definitely need to have a better understanding of the data and how it has been processed. So take that a step back, understand it. But purely looking at algorithms, you will have to really go back and understand the data concepts that we spoke about, statistical view of the data and dimensional view of the data. From there on, you will really be able to figure out, once you understand that data characteristic, what kind of algorithms are relevant, which is exactly the reason why I said some amount of statistical understanding would be good. Is GitHub skill important? It is, irrespective of whether it is data science or ERP or any other stuff. So GitHub really helps you in the process of SDLC cycle, essentially help integrate and adopt DevOps and CI/CD stuff. So whether you choose a career in data analytics or not, you should definitely have some understanding of GitHub if you can. Should I practice statistics related to machine learning or understanding is more than enough? You should definitely practice it. Again, as I said, you can probably get away understanding the basics if you are still in the analytics world. If you are getting into machine learning, you would need to have a deeper understanding than just theoretical knowledge. Okay. Difference between AI engineer and data scientist. Again, I don't really see anything like an AI engineer. Data engineer, yes. AI is more kind of a skill that folds up into data scientist. AI and ML, though not exactly the same, essentially kind of fall there. AI probably is a larger umbrella, because even if you look at things like something that you can automate with a system, that falls under AI, not necessarily a machine learning algorithm, like your chatbots, for example. How much cloud knowledge is required for data engineer role? Definitely good to have. I wouldn't put that as a mandatory thing, but without doubt, you are kind of having everyone using analytics moving on to cloud. So at some point of time, you will have to understand how the cloud works. So if you can get that basic understanding, that will definitely help. Do we need ML knowledge for data analysis? Not necessary. Again, as I said, the distinction between business intelligence analytics and data science is between them is slightly diverging, even though there is overlap. So ML knowledge is not necessary for you to get into analytics world. You can start with BI and analytics, and then once you start getting into advanced analytics is where you will need to pick up on ML stuff. What company expects from freshers for data engineering? I call that out. Programming expertise, database expertise, and essentially is a good understanding of data from the two different views I spoke about. That should be good to start. Brief about how data is collected at your organization. So data collection can be quite an elaborate topic by itself, but to call out 2-3 different ways in which data gets generated and data gets collected. One is obviously from your transactional systems. To give an example that you can correlate to your workplace, payroll, right? So once every month your payroll runs, data comes in from that, so that you can integrate all of the data at the end of the year to say, yeah, here is your overall income. This is the tax deducted that you can go and file your income tax. So that's one kind of a system wherein you are really having all that data coming in, which is more of the operational systems. The second one is a lot of that data that actually comes through in the form of unformatted or more of, I say, semi-structured or unstructured. An example could be simple mail exchanges that happen, right? So a lot of the time we ask employees to provide information and respond over a mail. So information that is coming in there can either be passed using programming techniques, or I can kind of look at it and manually note it down. So that's more of the how the unstructured data can come in through within the system. A third one is, again, lots of the systems that themselves throw up the logs of the data. If I am really having, let's say, a system within and I want to monitor who is using it, I will use the application logs to figure out who has logged in at what time. For example, with a lot of people moving to working from home, right? You do not have an attendance register. So how do you actually understand it? So a lot of the things that you do on your system are captured in the logs, and I can look at those logs and figure out how I can really make sense of that. Is person really spending enough time at office or not? So that's something I would call out as 3 distinct ways in which data gets generated, especially if you want to correlate more to a workplace like us. So last 2 questions. What challenges we should expect for freshers in big data analytics in upcoming span of time? Yeah, whether you are new or existing, you always have to be on the lookout for the newer trends. Unfortunately, we couldn't go back through that slide, but I can quickly bring that slide up. So if you look at some of those analytics and BI trends, it tells you that this space is definitely fast evolving. Well, I will not kind of get stuck with the 1 or 2. The 2-3 bullet points that I would highlight is essentially 1, distributed computing is no more a standalone computing thing. Edge intelligence that you see there, being able to work with the data just at one place and still be able to provide insights. That's a big, big trend. Second, we already spoke about the overlap between BI and analytics and how tool vendors are reacting to that. So that's, again, something that you should definitely be on the lookout as a changing trend. And the third one, essentially, I would say is more of the real-time analytics. It's no more like you bring all the data at one place, process it at your own speed and deliver it. Real-time analytics mean you are able to embed your analysis techniques that we spoke about actually into where the data is getting generated, so that you can provide those insights actually as it happens. A quick example, if you can correlate to it, is how you identify fraudulent credit card transactions. Again, if you any guys are using credit cards and have been a victim of that, you will know when some odd transaction happens, more often than not, you get a call from the bank or someone saying, yeah, this is a transaction, did you actually do it, right? Why and how that is happening? They are really able to interpret your prior spending patterns like you never gone to a pub or a bar and then a huge amount shows up on your transaction consumed billed at a bar, right? A red sign that they can quickly flag. So that's what I'm calling as real-time analytics, and one quick example of what it is, which is going to become even more prevalent. Okay, so with that, 30 minutes over. Unfortunately, I do see a few more questions coming in, but have to kind of wrap up now. Pretty happy to take in more questions. If there are any more, I'll kind of try and address it, and we can have mail exchanges. Otherwise, more than happy to kind of take on your questions in a different class or a different forum.
I think Srinivas Sarji, yes, thank you very much for your very wonderful interaction, especially in-depth understanding distinction between various roles and answering very patiently every question of the students. So thank you very much for that. I know there are a lot of students having many questions, but yeah, they can be addressed later. So thank you. We would like to thank you from CDAC side, Srinivas Lanka ji. Thank you very much for sharing your insights.
Hey, thank you, and all the best to everyone. I do wish you a very good career ahead, and hopefully you can kind of cross paths with EXUSIA. Definitely interested in getting folks who have that ear for analytics. Thanks,
yes.
and all the best again.
Thank you.
Thank you.
Thank you. Thank you all for joining.